Good evening, everyone. As we move closer to the vicinity of Horizon 2022, we at ISTE-VIT strive to engage young and eager minds with extraordinary knowledge. ISTE-VIT is back yet again with another enlightening event. I am Ved Purohit, and I am a representative of ISTE-VIT and the host for your webinar. ISTE-VIT is a national, professional, and non-profit technical chapter at VIT Vellore. Our goal is to provide quality technical educations in diverse fields of engineering to stimulate creativity and passion amongst budding young engineers. Today, we are conducting yet another inspiring event, Excavating Data Science. We at ISTE-VIT have planned an informative webinar by our distinguished guest speaker, Mr. Akarsh Verma, who is the platform architect of those Tau-centric labs. He's passionate about engineering challenges that have a large impact. He has taken a keen interest in data science and analytics systems and has expert knowledge in enterprise architecture. So without further ado, I would like to hand over the sessions to our guest speaker, Mr. Akash Verma. The stage is all yours.
All right. Hey, hi guys. This is Akarsh Verma. Am I audible to you guys? Can somebody confirm? Wait, can you just confirm if I'm audible now?
Yes, sir, you're audible.
Or YouTube? All right, cool. So let's just start this session. And the way I'm going to be taking the next 1 hour or 45 minutes is that there are three parts to the session. The first part will be where I'll talk about data science as a whole. What are the key things you could do when you want to start your career in data science? What are the constructs in data science? How does industry perceive it? Probably also talk about how does a hiring manager see it, right? When you probably apply for a job or something like that. This is more of an in-breadth session. Then we'll take a 10-minute, interaction discussion where people can post in questions to YouTube chat. I'm monitoring that live, and we'll be answering questions for probably 10 minutes. After that, I will jump over to AWS Cloud and show you an in-depth demo of a tool, which is how to do machine learning on cloud, and also explain how easy it is. Now, the demo will be about 10 to 15 minutes. It does require an AWS account and setting up few things, which I've already done. But I'll try to demonstrate as much as I can. So it's also a hands-on exercise for the second half of it. All right. So with that, I will start. Let me just share my screen quickly. Is the slide visible to everyone? Can some of you wait? You can probably confirm that.
Yes, sir, it's visible.
So in Teams, maybe do you want to change the perspective because I can see that slide is only visible to a very small part on the screen. Do you want to resize the Google Meet?
So I think it's fine, it's visible.
Okay, cool. So we will be talking about AI, and this is a little bit about me. I think Ved has already given an introduction, so I'm going to skip that mostly. I am an enterprise architect by profession, where, as he mentioned, platform architect. So I kind of design systems which use AI, right? So not really core into doing AI, but more like an end-to-end system design, and that's the focus. So I'm going to give you a longer breadth of the session. Okay. Now, the way we are going to be taking a course is, if you look at where India stands currently when it comes to AI, is we all, when we studied in schools, there was no programming class. At best, it was some elective, right? But now, even CBSE has acknowledged this, and CBSE is trying to teach AI as a strategy, right? There's a lot of focus on taking AI and learning AI and more as a vocational exercise. So, trying to be probably in the next 5 to 10 years AI ready instead of just being a little reactive. So there's a very deeper focus even from a government side to kind of teach AI, right? So that's the motivation, which can probably lead you to believe that once you graduate, right, there'll be a lot of opportunities waiting for you in different domains, all right? Now, with that, we will move over to the core technical discussion as to how AI is built and shaped, and we'll take a look at that. So, the first slide that I have is effectively about how human beings think, right? We typically react against a question. So, if there's a question that I'm asked, like what is an AI or what are you going to eat next, we will think over it and answer. That's how typically human beings think. The word computers, the way computers will work is you will have a lot of inputs. Then you can have certain rules, and then you will have an output. Very simple to as the programs that you use, right? For example, as simple as calculator. You will give some instructions. There are certain rules, for example, additive rules, multiplicative rules, and these rules are what give the output. So that's how computers work, and that's how we, as we looked in the previous slide, how human beings work. Now, there's a little difference between the traditional style of computing and how machine learning systems work. And this difference is key to building on the knowledge as to how AI works. So on the left hand side, if you see in the slide, traditional programming where your code effectively takes data, there is a program, and then you get an output, right? But the idea is that the rules that are there, the complexity that is there, it is known. Whether you interact with a website, whether you interact with Facebook, the rules are known, right? But when you move over to the machine learning part, right, those rules, those patterns, that is left to the computer to determine, or more so specifically, algorithm to determine. This is a fundamental shift in the way computing takes place. So if you see on the left hand side, it's data and a computer code that generates some output. But in machine learning, you give data and you also say the output, right? For example, you want to take stock prices and say that, these are the stock prices over the past 5 years. Can I take this data, give it to machine learning algorithms, give it to computers, and can they find a pattern inside, right? And that's the whole game about machine learning. That's the whole game about data science. People are chasing the future and trying to understand patterns in data. Now these patterns could be in different part of domains, which we will look in the next few slides, right? So that's where the difference lies: traditional approach versus machine learning approach. Now, I'm not trying to debate whether one is good or the other is bad. Not trying to undermine that at all. The traditional form of computing is pretty much what powers a large part of the industry, right? The world as we know it, the systems, even this tool that we are using, right? Google Meet. This is a software which has been built with certain rules, right? So this is not a fight between two worlds. It's more of both have different roles to play in the world. The first is to make software systems, traditional softwares, the ones that power the world. The second is to build more intelligent systems, and the approach that they take when it comes to programming is different. That's the key message. All right. Now we'll move a little bit forward and try and understand different constructs that are there. And I'm going to be talking through words and less through slides now. So what you see is a very popular problem, right? And some of you might have heard the word neural networks, right? And the idea is that can you teach a computer to differentiate between cats and dogs? Now, this problem is falls under the bucket of problems for called computer vision, and this is a relatively solved problem. It's nothing new, and there are more cutting edge areas in computer vision which we can discuss. But this is where it all starts, right? You want to make a system which can differentiate between objects, and cats and dogs are just the training part. You can do a whole lot of things, right? You can have a computer program probably differentiate objects. You can have them differentiate humans, human emotions. They can try and understand live in a video feed where the human being is, probably what you see me on the video, right? There's background blur happening and all that. Some of that is powered by AI. So this is a use case where you have neural networks and you kind of work towards understanding computer vision. But when in my interactions with people who have been fresh out of college, I see that a lot of people just jump to this, right? Just jump to the more cooler part of machine learning and AI, which is neural network, deep learning, GANs, and all the good stuff that is out there, right? Some of guys will just talk, say, I know LSTMs and we have done this and we've worked on these competitions, all right? Now, what I'm trying to communicate here is there's a step-by-step process, and given that you're in college, it makes sense to learn and go through that and not just jump the guns because the foundations are relatively important, all right? And with that, we'll just move forward. So if you also take a look around, and this is more of a random realization slide, that if you just take a look around in your home, you'll find that all the smart devices that you have, all the home automation devices you have, the Alexa, Siri, Google Now, Google Maps, all of these are very intelligent systems, right? AI is all baked into it, but at the same time, they are software systems, right? So again, going back to the slides of traditional versus modern or machine learning, don't make it a fight in your mind. Both are needed. It depends on your interest where you want to pursue it. All right. Now we'll come and move forward to a couple of definitions. And the reason that I bring this slide is usually all of these words are spoken in the same sentence. And one of the key challenges with that is it makes it difficult to kind of study them, right? It makes it difficult to understand what is being talked about because each technique or each method kind of just give me a second. Sorry about that. So each technique or method kind of have its own details and depths to it. All right. So I'll just move forward to the slide and use the pointer a bit. Just give me a second. All right. So what you see on the left hand side, right? This whole Venn diagram, the word data science is very popular, right? It's one of the most hottest buzzwords right now. But was it what does it comprise, right? That's what we are probably trying to see in this image. So it's a combination of couple of areas. So when we talk of computer science IT, which is the core computing, right, and the convergence of machine learning and statistics, you have some kind of machine learning coming up, which is this part, right, which is the blue part. Then when we have computer science and business, you have the normal traditional software development happening, and when you want to go more on the research side and not on the software side, you can have probably math, statistics, and the domain knowledge. Now, domain knowledge really means is what industry do you work in? Because computer science or technology effectively aims to solve a problem. Now, the problem has to exist in some domain, for example, banking, for example, travel, retail, finance, healthcare. Those are what are typically business domains or insurance. There's tons of domains out there, right? So when you have math statistics domain, that's where more of research comes in. Now the convergence of all of these three is typically where data science is looked at. What does it imply for you is a little bit of knowledge from all the areas or specialized knowledge from one of those areas depending on your interest and your skill is where how you will move forward, right? So that's effectively where the core lies. Now on the right hand side, just focusing on AI, ML, and deep learning, AI is a broader term. It is more about the ability of machines or computers to mimic human behavior. And the best case examples probably to have a more generic AI would be to have some kind of robotics where there's a robot which is mimicking human, and we are very far from that, right? It's extremely far. Then you have machine learning, right, which is more of a subset of techniques where you uh, technically rely on some kind of statistical methods which are largely based in maths. I would say simpler maths because deep learning is also based on math. And that kind of, helps get into the world of machine learning. So the library sklearn is typically a good example of where you play a machine learning if you're from the Python world. Deep learning, finally, deep learning is a technique where you rely on neural networks, right? So there you have a different and a different structure of model. It's much more complex, much more dense, and traditionally speaking, different kind of problems are suited for each of the types of learning. Now, even beyond this, right, different learning techniques have come in. Now, the categorization is a little gray, but you have reinforcement learning, which is more of a penalty-based setup, which is to reward and penalty-based setup. So RL is another area which is very popular in the world of AI. It's also gaining a lot of traction. There is a newer type of model category which has come up, which is called GANs, which is more generative networks, which typically are used in data augmentation or more creative problems. So different kind of neural network. But understanding the taxonomy and differentiation would be really, really important for you guys to begin with in your career. All right. Now, let's just look at some of the fundamentals that you need to probably study around. Now, the first foundation and most of the guys that probably we interview, they kind of skip this lecture somehow in their AI and machine learning class, right? Learn math, stats, and probability while you're in college. Pay enough attention to them. You don't need to be a expert in them, but make sure you understand the foundations of it, right? Because probability, for instance, is a bedrock. It kind of, if you when you talk about future, right, it's not certain. So if you think about philosophically what AI aims to do is to predict future in certain forms, the results are always going to be probabilistic, right? So that's where probability comes in. A very good and deep understanding of it is gonna, pay a lot of help to you. Then going back onto statistics, right? We don't pay enough attention when we are college, but very simple things, right? About distributions, normal distribution, what is mean, what is median, what is mode. These differences, sometimes these are not clear to people, right? Specifically when, the notion of AI is all grandeur. So try and pay very strong attention to stats, because once you do, you'll be able to scale on it very quickly. If you do not, then you will still be able to start, but suddenly start fumbling around as to what this is, how is this done, etc. And then finally coming back to maths, a couple of topics in math. Linear algebra vector is relatively important to understand, not extremely deep, but I think everything that you guys have studied till probably standard 12, and I was told that most of you guys are first year, so or second year probably. So whatever you would have studied till standard 12, that maths is more than enough to help you start in learning AI and machine learning. But it is a good idea while you are in college to prepare probably a book or a notebook which can become your ready reckoner and guide to concepts if you want to refer in future, right? So that's where we are. Let me just quickly, okay, we'll take the questions probably after this. The second is programming skills, right? And there's a lot of debate, uh, very large debate around what programming language to learn. Be it Python, be it R. I know Java. I want to do JavaScript web development. The good news is all of them work, right? They are a means to an end, and the programming language was going to be always there, right? Whether you start your career now or probably 10 years from now, right? There's already languages like Julia picking up in machine learning world. In academics still, there's a language called Go, which is very popular in the world of machine learning operations, because it's kind of very well perfected on all that. So when you take your programming classes, right, it is important to pay attention to two pieces. A, learn a language and master it. Be it any language, it's best if you can stick to an object-oriented language. Not the most important thing. You can still do with C and C without the object-oriented, which is not the C++ version, right? But it's highly recommended that you read and study C, C++, and data structures. Now, data structures are foundational to almost everything that you're going to do. Now, it does not mean that you need to be expert at competitive programming and being able to solve all of those, crazy complex problems, like figure out how many queens can be there, eight queens problem, the ones that you find on HackerRank, all right? Not demeaning them, definitely needed if you want to make that career path, but purely in data science, you need to be aware of the data structures. You need to be aware of how to use them. More basic ones like arrays, lists, circular lists, trees, etc. Right? So pay very strong attention to them and practice. Now, when you know these two, right, the fundamental ones and fundamentals two, right, whatever programming language you have learned, try to code a statistical technique in that. For example, take a series of numbers and try to apply all the mathematical concepts that you have learned raw in loops, in iterators, in variables without the help of libraries. For example, if you were to code mean, so instead of math.mean or whatever is the library, take the sum of all those variables, add them iteratively, and divide them by counting. That will give you a very raw understanding of it. And this is a method that will stick with you for very long, because this will enhance your coding skills and also give you a very in-depth understanding of how each of them work. Because once you graduate, right, you will be solely working with libraries, and sometimes the deeper understanding of them is going to stay with you and help you much longer in the future, because you have the ability to ignore that library and just come back to coding it. All right. So that's probably something which I always recommend to kids. Now, moving in a completely different direction, let's just probably take some questions at this stage if there are any. I want to check that. Okay, there are no questions so far, so no problem. Wait, please do put questions if you have noticed any questions, guys. I would encourage you to kind of put questions in in the YouTube chat and all of that. Okay. Now, now I'm going to talk about different types of problems that we have in AI and different kind of domains and different kind of problems that we perceive. All right. So the first is prediction, right? And this is the simplest forms of prediction. There can be more complex setups. The algorithm uses linear regression here, and the idea is that given certain data points, right? For example, this is your independent variable. These are your there are some dependent variable. Let's just say y is equals to mx plus c equation, and we want to define the line of best fit, which is the line of regression. So the idea being that whatever is the whatever the data points are there, this is the line that best explains that. This is the line that is closest to all of them using certain technique of finding a distance metric like OLS and things like that. This line can be used to predict in the future, right? So if a new dependent variable comes, for example, sales figure, right? So that can be taken in, and you can predict the next sales target, right? For example. So whatever is the dependent variable, you can probably use that, create a model, and just have a line of regression. This type of problem where you're trying to predict effectively most of the times numerical data is called prediction. It's also called regression problem. All right. The next is a classification problem, and classification problem is cats, dogs, zeros, one, multi-class problem where you have certain two, three different categories. Like for example, you got marks from whole college, and some of the data is labeled, and you kind of have them labeled as bad, good, very bad, and all that, and you want to build a model irrespective of who the people are, that given these marks, where would they fit, right? It could be grades and things like that. So that becomes a classifier, right? You're trying to classify people based on certain parameters into a bucket. That effectively is a classification problem. On the bottom, you can probably see that the algorithm, one of the common algorithm used, again, this is not the only algorithm, it is called logistic regression. All right. So that's the classification problem. Next is when you move from traditional regression classification problems, there's more complex problem comes in. Now, what I've talked before are machine learning and statistics driven techniques. But now I'm trying to move into more deep learning based techniques. It does not imply that you cannot solve these problems with traditional approaches. They do exist, but there could be a very strong argument about what works best for larger text and all that. Okay, so the first problem is we are talking about natural language processing, and human beings are kind of obsessed with trying to understand the text and speech and things like that. That area is where NLP tries to aim at. So whatever I'm trying to say, right, whatever I'm trying to talk, that is speech, right? And there's a lot of English that is going in, whatever is the language. There are certain grammar components which we probably can take a look in the image. So if you see this, right, this is an article from somewhere back in 2000, People magazine highlighted Prince William, and so on and so forth. Right? There's tons of information floating around. All right. So what NLP tries to do is it tries to identify what are the parts of speeches here. What are the entities here? What is the information trying to be communicated? What is the person who has spoken or written trying to communicate here? All right. So the first is a publisher, which is a very right statement. Like People Magazine is a publisher. Prince Williams is a person, and this depends on whether the NLP model knew Prince Williams or not. Navy is a color, suits is an item, and you see there's a lot of different parts of speeches that are being tagged, right? These kind of problems are NLP problems. The extension of these problems are, when you are able to do this, you can figure out a lot of stuff about what is being said. For example, sentiment analysis, right? Very, very common problem. Some of you have already done it and worked through it. All right. So that's probably where I would say NLP aims to be. Now, from a technique standpoint, it is it's a probably, I don't know, semester of course in itself. It's a very vast topic, starting from an understanding of linguistics, how language models are created, traditional algorithms like bag of words, TF-IDF, frequency-based counts, to moving to more common and popular ones like LSTMs, variants of RNNs, there's transformer-based architecture. These kind of networks are gaining a lot of popularity in NLP-based problems. All right, I'm gonna take a pause because I see. So, Ved, a quick time check. How much time we have spent? How are we doing on time, Ved?
So around half an hour.
Okay, cool. Let me
So
just
you
take
can take so much time.
cool. Let me take questions. I'm gonna look at the side. So there's a couple of questions. So we can go for Java. Am I right? So yes, you can take Java. In fact, I'll give you the name of the library. I think it's called ML4J. If I'm not wrong, ML4J. I will take the library name and put it in the chat. You There could be other libraries as well, but ML4J is relatively popular. The regular language of choice has been Python, but ML4J is equally good. How do we master the classification problem? I think I really don't know what to say to that. What do you mean by master the classification problem? You will need to have data. You will need to perform some sort of an exploratory analysis on top of it. You will need to be able to frame the right question as to what are you trying to classify. Because if your classes are not clear, then it becomes difficult. Couple of things to check for is if the data that you have is balanced or not, meaning all the classes have same amount of data or not. So probably check for imbalanced classes. And then you'll have to try different modeling approaches depending on the problem and probably measure it against a confusion metric or precision recall, F1 scores, and all that. It could be a relatively long conversation, but that's how you would approach almost any machine learning problem. Won't machine learning algorithm risk becoming inaccurate as the amount? Absolutely. This is a brilliant question, guys. So what this is uh, there's a concept called model drift, which means that over a period of time, as more data is gathered, uh, you know, their ability to predict decreases. The term is called model drift, DRIFT. Now, this is a very common scenario to study. What you do is you study this, right? You always try to see that your model was predicting what are the actuals, because after a certain period in time, you will be able to get the reality of it, right? For example, you were predicting sales target for the next 6 months, month on month, right? So you will have a line which will be more like, I'll probably try to draw it on the screen if I have a pen. Yeah. So we can take this. So let's say you have a line like this, which is what you predicted. And let's say the sales numbers were relatively like this. So the difference has to be fed back. The model has to be retrained. Although the chart is not right, but drift is a very common concept. I would say not so common concept. Actually, you need to pay very strong attention to it. Uh, how do I go about learning? Okay, what are the best? Wait. What are the best resources to learn from? I think YouTube is the best resource if you want structured courses. You can check out Udemy, you can check out Coursera. Pick any course, right? Pick any MOOC and complete it. That's the most important part. Most people do not have the problem of taking a course, it is finishing the course. So take one, make sure you spend time in, seeing through the trainer by evaluating the course, like is the voice good? Because some trainings are just sleepy and all that. So make sure you kind of select a training and stick to it. Coursera has tons of free courses. Udemy has tons of free courses. There's lots of places you can do. You can just go and look for popular YouTubers, and they could probably be there. I think Chris Nayak does a wonderful job in that. You can check out his YouTube channel, and there's a lot of stuff that he teaches. Most of the information that you need is available free of cost. If you want the structure, pick any good Coursera course, and that will give you the structure, and you should be able to make your own, course by writing out YouTube videos. All right, I've tried to answer some of that. One of the person is asking, how do I go about learning data science and ML for quantitative trading? Good. Uh, Dude, I'm guessing that you already know quantitative trading. I'm also learning this right now because this is a very new area for me. There's an institute called QuantInsti. I'm not sure if I'm not endorsing them. I'm also a student there. You can check them out. You have certain very niche YouTubers who kind of talk about using machine learning techniques in quants. Very, very relatively new area because the traditional style of quant still works. You'll have to probably re-talk to me separately, or just ping to me in one of my videos in my YouTube, and you should be able to. I should be able to give you references. Free platforms you can learn from. All of the platforms that I named are free. I think you can learn from Coursera, Udemy. Is DSA needed for data science and ML? I would say yes. Anything where you need to code, right? An understanding of data structures and algorithms really, really help. For example, how does a search work? How does a sort work, right? These concepts are very useful when you're trying to build softwares because remember that machine learning systems are not like, not going to run in isolation. They are going to be part of a larger ecosystem or a smaller system, right? So a knowledge of DSA definitely helps. All right. What is the major difference between data science and data analytics? I think data analytics is more of a traditional word. Analytics is the domain. From an organization standpoint, data science could be, generically speaking, like I talked in my slide, convergence of algorithms model. Data analytics could include a couple of other things. For example, BI, which is visualization. You could also do a data warehousing in analytics. A lot of reporting stuff happens. So that's the difference, I would say. Uh, Not something I would probably suggest to worry about. These are just terminologies. Probably you can go much more deeper. Sir, what are your thoughts on the uses of Kaggle as to what level? Okay, two things. Kaggle is great for practice. That's not how the industry works. You get amazing data in Kaggle, you get shitty data in industry. All the data that you get is dirty. What Kaggle probably does not teach you is, the data cleaning aspects of it and understanding the data and even gathering the data. So knowledge of how to work with data, data transformations, cleaning the data is really, really important. So Kaggle is great for learning and practice. Participate in competitions, be a great coder, amazing stuff. But don't start calling yourself that I'm an amazing data scientist because I've solved 10 Kaggle competitions. If you're top of the line, if that's where you are, probably true. There are a lot of people who are grandmasters and have huge respect for them. But solving 10 problems and probably, imagining that this is the end of the world or this is what is there in the industry is not a great idea. There's a lot of gap between that. All right. Oh my God, there's a lot of questions pouring in. Okay, I'll go trading. I've done uses of Kaggle. I've done real applications of NLP. Tons of them, dude. Sentiment analysis is there. Document summarization is there. You have topic modeling, which is there. You have recommending, for example, what you use on Google, right? Next word recommendation is there. All your grammar corrections are there. There's tons of use cases. Speech to text are there. Okay, what are the NLP? Are transformers part of NLP? Yes, transformers can be thought of, they're model, they're deep learning based techniques, and yes, they can be used for NLPs based problems. How do you solve any data analytics? How do you approach solving any data analytics products? Okay, here's my own individual take on it. I think before the word analytics, The word data needs to be understood. What is the data and what is the problem? Post that, analytics can happen. Because unless and until you have a problem you are trying to solve, all data is noise. So make sure you understand the problem, take a very hard look at the data, define the question, and then move forward. Beyond that, there are very well defined frameworks. For example, Crisp DM, which is by IBM, is an amazing framework, probably most popular one also for data science problems. It's called Crisp DM. So, Transformers Pada, how do you approach solving any data analytics problem? Can NLP be used for making efficient chatbots? Yes, absolutely. Look at Rasa. That's a great framework for doing chatbots. Courses, I'm sorry, I do not suggest or recommend any courses from my own side. I think it's best to, find your own path in that. It's relatively easy to go on YouTube and Google around. What kind of accuracy of models, for example, of a confusion? It's a very difficult thing to answer. What is a good accuracy? I would say if you can be 60%, for some problems, great. Certain industries are very low, that 60%, 70%. But I'll tell you this in the other way. The ones that you see in Caval competitions, like 99.9976295,100, that kind of accuracies are not achieved in industry. Very, very, very hard. But yeah, 60%, 70%, sometimes 80% in very, very solved problems could be there. Great, Abhishek. I think it's great that you're taking that course. Feel free to collaborate with me. Would love to learn from you at the same time. All right, I think Ved, I've answered most of the questions that are there. Let me just get back to slide and the demo. Cool. The next is on the slide is recognizing handwritten text, right? This is again a computer vision problem, very old problem. Uh, the bottom line, what you see over here, right? This just talks about the number of lines of code. It's hardly 11 lines of code, which can recognize handwritten text. Very, very cool stuff. The code is from TensorFlow. You can find this online anywhere. The problem is again computer vision problem, and the idea is that you have so many different forms in which handwriting can be written, and you kind of then again, try to predict what character is it. These are relatively old problems. Again, computer vision problem. This is probably from YOLO, where the CV model at the same time is trying to predict so many different elements. Traffic light, tons of traffic lights. You see this, it's so small traffic light, right? Very, very small traffic light here. No idea why I did not pick this. No model is correct. There's a lot of people here. There's a handbag, which is interesting. I wouldn't have seen it. Uh, Car, truck. I don't know how it is differentiating. It could be wrong or right. Difficult to kind of understand. What else is here? Yeah, I think the idea is that it just does a lot of, this is more of a single shot detection. If I am not wrong, though I'm not a person who typically knows how to code this, I can implement the system. I've seen some models which can even tell this is building, this is cloud, there's flags, there's windows, all of those funny things can be done with this. All right. Finally, I think just at the before I say thank you for the slides, this is not the end of the session, guys. But the government of India has recognized that an AI-driven economy can really transform lives, right? AI is a driver for a lot of socio-economic transformation in the country. And I don't say this, this is from, some government of India, some stack which was published, right? And this is one of the core principles that have been taken by Niti Aayog in a national strategy paper. It's extremely, extremely important that you guys understand the importance of it, and whatever role you play in your careers, be it become a data scientist, become an engineer on cloud who deploys data science model, or become a computer vision engineer, become an edge AI person. It is important to know that there's a lot of focus towards AI, both from the industry and government, and that's a very sweet spot to be in, right? IT in India IT in India has been more of a service provider, right? The large service-based organization. We provide services to the different parts of the world, right? Nothing wrong with that, but Now this is driving innovation, right? So with that, I'll just conclude the slides and move over to the demo. Uh, all right. Where do I? What do you guys see? Let me just check YouTube channel. All right. See my screen or browser tab. No, I don't get an option. Okay. So what I am now going to talk about is AWS. Okay, I don't see that. Is my screen visible?
Yes, sir.
Are you sure about? Okay, yeah, I can see that. All right. So what I am now going to talk about is AWS, which is a very popular cloud provider, and I'm going to be showing you a service which is called AWS SageMaker. Now, please pay attention to this because this is a relatively, advanced discussion. The idea of bringing this to you guys is to show you how cool and quickly you can learn ML and also implement a use case. Now, this use case is probably very small, but you can scale the idea. This is not a training for AWS SageMaker. I've done a couple of videos on my own channel. Probably I'll give you the link at the end of the session. You can check that out. You can check out Chris Nayak's video. There's tons of content on the internet, right? This is more of a demonstration of it. Now, what I've already done is I've created an AWS SageMaker account, which is probably what you need, and I've already started Canvas. Now, AWS SageMaker comes in two offerings. One is the Studio, which is a very large scale offering, and Jupyter Notebook kind of environment, and you can probably take that. And the other one is SageMaker, which is a newer addition to it. It's an AutoML tool. It's very visual in that sense, right? What I've done is I've uploaded a data set beforehand so that my life is easy. It's also easy to import data set. You just click on S3 bucket, you select, and you have the data set here. I've already imported this, so no need to re-import it. Now, then I'll go to models, right? And again, I've built the model, but I'll also create a new model, right? We'll just see how easy it is to create a model. So let's see if this one works. So this is an iris data set. I'm going to be trying to predict whether what sort of distribution it is. Okay, this is small. Sorry, it doesn't work with this. I'll take the different data set. We'll take this data set. And the problem with the previous one was that it was not having enough records to build a model. No worries there. So this is the data set is basically Titanic data set. For people who are not familiar, this is from Kaggle. It's this data set. What it tries to do is, you know, there's a lot of information on Titanic, what sort of people, these are the features basically. So passenger ID, whether they survived, what class they had, what was their gender, what was their age group, what was the type of ticket they bought, some information about that, right? Whether they were in cabin or not, did they on board or not, and things like that. I'm only interested in whether they survived or not. And the point is 0 and 1. It already says that, it automatically looks in the data and it figures out that 63% did not survive, or, okay, I think 0 is survived, whatever. I have totally forgotten that, but let's assume that 0 is survived, 1 did not survive, just to be a little more positive about human life. Uh, you can change the model type, which means that what are you trying to predict? It's a two category model, three category model, etc. This is a two category model, 0 and 1. And you can do a lot of options. You can do a quick build, you can do a standard build, right? Quick build is relatively fast. Okay. And once you select this, it will allow you to, build the model very quickly once you click. And then you can analyze. Now, I'm going to go back to the model that I've already created so that I don't repeat the training cycle and not incur a lot of cost. All right. Yeah. So this is the model which I've already built. What the heck? Yeah. So the same thing, which is what I've done, select, build. I've already built the data and model. And I've already analyzed it. This is giving an analysis, and it is basically taking gender is important and things like that. Okay. Then it is trying to predict, and I've already generated a prediction, so I will show you. Now, what you see over here is it is trying to predict what whether the person survived or not, and here's the probability against each of them. Right. So this is an AutoML tool. The process is you select the data, which is what I did in the first step. The second step is build the data, right? Build the model. Sorry, not build the data. Select what is the target column. Select the model type. You can even see the data here, right? You can figure out what the data is doing. Then you can analyze it, right? How the model is working. You can check some scoring, right? You can see some metrics. You can see some advanced metrics like confusion metric here. And while this is saying 100%, let's not go with that. This is a very quickly built. It's not meant to demonstrate the accuracy. It's meant to demonstrate the capability. So you have very nice, scores here when it comes to data, and you can see all of these things. You can see that this is out of the box, right? The tool itself is giving you. All right. So that's the beauty here. What else does it have? Let's see. So yeah, the predictions you can already click here and predict. I've already generated the predictions, and here you can see some impact with each of the column. It's trying to showcase you some sort of impact. And then when you predict, you'll be able to get either you can predict a single prediction, or you can select a data set, which I already did, and see the results. Here you'll be able to get the results. So this is an AutoML tool, which is kind of generating the modeling for you. So you can use this to probably play around with data and start to love data science and machine learning, right? So this is a relatively cool stuff. The other side of SageMaker is much more deeper, which is a SageMaker Studio. Just quickly click on that. Oh, yeah, sorry, it's already clear. I'll have to launch a studio and it'll open a very familiar Jupyter notebook environment. I'm not going to do that right now because it just squeezes a lot of resources and takes a relatively long time. But it gives you a Jupyter notebook type environment. All right, so that's pretty much what I wanted to share. I would probably request you guys to shoot in your questions much more now. We can talk about cloud, we can talk about data science, how to take tools, some technologies. If you're interested in some very specific tool, you can probably ask me a question there. Yeah, open for questions, guys. Also, what you see on my screen is my YouTube channel. I would highly request you guys, if you like what I discussed, to go and subscribe to it. I talk about these stuff which I've already talked about in this session. So please do subscribe to my channel. I will just paste the link in the chat. Okay. Okay, let's hear some questions, guys. You can go to the link and subscribe to my channel. Please throw me more questions. Right? Please go and throw me more questions. I think that's what this session will be about. Won't machine learning algorithm risk becoming inaccurate as the amount of data increases with time? Yes, they will, Shivangi. I think, Shivangi, I've talked about this, but I'll repeat. So, this is a concept called data drift and model drift. As the data, is added, machine learning models also tend to reduce and degrade over a period of time. This is a very common phenomena. It is well studied. What we do is we monitor the model over a period of time and see how is the decay. Is it within acceptable limit, or is it like going absolutely out of whack? Whenever we feel that it is about to decay a lot beyond a certain threshold, the model is retrained. So it's not like a machine learning model which is created today on 1st of, let's say, April is going to be the same on next year, right? Model trainings are a constant exercise. And in order to kind of deal with that drift that you're probably trying to identify, training is needed. Okay. Any more questions, guys? I would definitely request some of you to please go and subscribe to my channel. That would really help me out. Guys, please shoot more questions. I think we have a couple of minutes. Wait, we do have some time, right?
Yes, sir, we have some more time. We
Okay.
can take a few more questions.
Can the tool used in the webinar be said to undertake unsupervised learning? It can do unsupervised learning, but I have not tried it. You can definitely do unsupervised learning with SageMaker, Studio, but with Canvas, I have not specifically tried unsupervised learning. But yeah, you can do unsupervised learning in these tools. There's no questions or challenges there. Okay, please shoot more questions related to tool, right? If there's a problem with computer vision, if there's a problem with cloud, let's talk that. Okay, there's a thumbs up. What's the main difference between supervised and unsupervised? So, supervised learning is where you have labeled information, right? Where you have applied labels, right? Unsupervised learning is without labels, I would simply put it that way. So with supervised learning, that's pretty much the difference. So what does a label mean? That you have some data and you know what this data is for. An example of unsupervised learning could be, clustering problems where you have some customer information. For example, I have lots of information, right? I have the information of 10,000 customers. They belong to, there's different data points available there. Some of them that is, for instance, how do I put it? Some of them belong to large economic zones, some of them are lower, some of them are below poverty line. So, unsupervised learning would be trying to create a model, trying to create cluster from that. So that's what is unsupervised and supervised learning. There are more questions. What recent in-fields project the industry is focusing on? There's tons of work happening. Where I work, we work very extensively in time series. I think if you guys open, we also work on commodity price forecasting. Very similar to stocks, we try to forecast commodity prices. That's one product that we have in my organization. It's called Price Vision. Pricevision.ai. You can check that online. It's relatively easy to find. It's on public domain. There's another tool which is very niche. We try to do demand forecasting, which is supply chain may you're always in need of more understanding how the future is going to be, right? So we have tools for that. Most common use cases are in forecasting and trying to predict. When you look at general, there's a lot of supervised learning happening, there's unsupervised learning, but very recently, a lot of stuff is happening on NLP too, though not so much. Computer vision is still a very niche use case. Commonly speaking, there are some specialized use cases for that. But computer vision, since it requires a lot of computing power and also the camera qualities are not always of the nature that you would want to do. So computer vision is still probably, I would say, not intensively popular. Yeah, so that's where we have work going on around. So can we get machine learning jobs after BTech, or should we try to focus MTech and go for it? Uh, I do not know. I think I've never done a MTech. I would love to do that. I'm still BTech. It's been 10 years since 10.5 years since I finished my engineering. So yeah, I have not done BTech MTech, but by all means, do chase higher studies. If you are interested on the academic sides and more deeper insights. Uh, Getting a job or not getting a job, I don't think is tied to BTech versus MTech. I know good diploma holders who are able to uh, get jobs very easily. I think getting a job is more about how you perform individually as a student, how you have learned, how you have how you have how you conduct yourself, right? What is your attitude towards learning? uh, what is your attitude towards interview? How do you present yourself in interview? How do you communicate your knowledge? For instance, a lot of kids would probably just start with saying I've solved 10 kaggle problems, as I said before, and say that they know 200 different things. I think if your glass is already full, then hiring managers typically do tend to look at that as a negative trait. Specifically in freshers, I'm not saying there are geniuses are not there. They are there and they are picked. but I would say it's more to do with your individual attitude and aptitude rather than your specific degree. What is an anchor box? I have really no idea what is an anchor box. What is it? I need to Google it. I have never heard of this term, so please help me understand it. All okay. Any more questions? I would also request. I can see there's 60 plus people here. Please do go to my YouTube channel and subscribe. That's going to help me out. If you want to watch and learn more on SageMaker, please do check that. There's a video for AWS SageMaker. Uh, please do shoot questions. Can Where I leave it on to you to when to call it. I think people have shot a lot of questions, but there is. I think we are almost about to get over on time. So please do ask questions, guys.
So we have enough time to take a few more questions.
Okay, I'm fine. Guys, please feel free to shoot questions. I think I should have just prepared for more longer slides. But please just type in chat. You can go to my YouTube channel later after the session or whatever. Sorry, that's not the one. Which platforms can be used for cloud computing? Interesting. Uh, almost all popular cloud providers, be it Microsoft Azure, AWS, GCP, they have options to do machine learning in different flavors. For example, Azure has something which is called as Azure ML Studio, which is machine learning studio. You can do a lot of visual machine learning, so as to say, like, drag and drop or select algorithms, drag the data, very similar to what I showed you right now. Then AWS, I think I just showed you AWS SageMaker is there. Google Cloud has something called as Vertex AI. All of them can solve large scale problems. I think scale is a parameter that is a little misused. All of the cloud providers can help you solve great problems, and they can help you solve it at scale. Um, yeah, I would probably say that. Sorry, sir. I meant large scale cloud computing. Yeah, that's what I was trying to say. So, all the cloud providers, be it Microsoft Azure, be it Google Cloud, be it Azure, they can help you solve large scaled AI problems. What you need to understand about scale is not a function of the cloud provider. Scale is a function of your own, design, how you have designed your software. So that's what I will probably answer. Okay. Any more questions?
So if there are no further questions, I think we can
Yeah,
conclude
we
the
can.
session. There
Is
seems to be
cloud?
no questions.
Yeah, absolutely. Well, the whole idea of cloud being safe or unsafe is probably a little bit overly, spread. I don't think it is unsafe at all. Again, safety or not safety is how you have stored the information, how you have designed the system, what services you have used in cloud. Uh, there's a couple of videos that I've done on cloud, not on security, but you can check them out, and you can probably try to ask a question there if you have a larger question, and I can try and answer it. But to answer it very directly, yes, cloud is safe for personal information. Thank you. Any more questions? Okay, then I would just thank you guys. Thank you for your time. You know my YouTube handle, just a self promotion. I kind of live stream every Sunday, 10 p.m. Feel free to join in. Thank you. Wait, should I sign out or wait?
If there aren't any further questions, I think we can conclude the session.
Awesome. Cheers. Thank you guys. It has been pleasure interacting. Bye bye.
Thank you everyone for joining today's session. It was a pleasure having you with us at ISTE-VIT. For all further events and further details, please do make sure to check out our Instagram page and our Facebook handles as well, and follow us on all social media handles. For further exciting events, do make sure to follow our social media handles, and also please make sure to fill the attendance form that is present in the chat box. Thank you so much for joining us today.